We usually assume that measuring the stars requires modern, post-Enlightenment tools, precise glass lenses and orbital sensors. Ancient Sanskrit manuscripts offer a different method. They contain structured data layers embedded directly within the meter of religious poetry. Take the poet Goswami Tulsidas. In 1575, decades before the telescope appeared in Europe, he wrote a devotional hymn called the Hanuman Chalisa. Within a single verse of that 16th century poem, we find a calculation for the distance between the Earth and the Sun. Seeing an astronomical equation inside a hymn forces a reconsideration of where religious tradition ends and empirical observation begins. The verse reads, Jug Sahasra Yojan Par Banu. It describes the figure of Hanuman leaping into the sky. We can extract numerical values from those specific Sanskrit terms. Jug represents a scalar unit of 12,000 years, and Sahasra means 1,000. Yojan is a unit of length equal to roughly 8 miles. When we multiply these three variables, 12,000 times 1,000 times 8, the total is 96 million miles. For context, the mean distance recorded by NASA is approximately 93 million miles. The 16th century poem lands within a tight margin of modern measurement. Translating orbital mechanics into a rhythmic song was an effective way to preserve complex data through centuries of oral tradition, long after written records might have been lost. The poem says Hanuman flew to the sun because he was hungry, mistaking the star for a sweet fruit. From a biological perspective, the sun is the raw source of every calorie we consume. Through photosynthesis, living organisms convert solar radiation into chemical energy. Every calorie in our food chain is solar energy in a different form. Hanuman's hunger describes the reliance of the entire biosphere on its ability to capture solar radiation. Using the metaphor of an edible fruit makes the foundational principles of energy transfer accessible to anyone, regardless of their formal education. We can see this same pattern in the physical act of chanting, specifically when focusing on the name Rama. This cross-section shows the mechanics of the vocal tract. The syllable Ra requires the tongue to curl back toward the hard palate, engaging deep musculature associated in tradition with the release of internal energy. The syllable Ma shifts the vibration to the nasal and sinus cavities. Research into sustained nasal humming shows it can increase nitric oxide production by up to 15 times, helping to widen blood vessels and improve circulation. The linguistic root of the name Rama means to come to rest or stand still. These phonetic mechanics trigger measurable biological shifts, resulting in a lower heart rate and regulated stress levels. This practice extends to the final transition of the human experience, the moment of death, through the funeral chant Ram Nam Satya. In India, the dead are carried through the streets to this rhythm, providing a visceral reminder of mortality to the living public. While the chant is intended to liberate the spirit of the dying, it functions as a stabilizing anchor for the mourners walking behind the bier. The repetition serves to interrupt the mourners' attachment to daily material concerns, focusing their attention on the shared reality of death as the ultimate equalizer. By actively integrating physics, biology, and psychology into daily rituals, ancient civilizations ensured their observations would outlast physical libraries. They built a method of knowledge transfer that survives as long as the people who repeat it.